So for today, it's called binomial expansion. This is a difficult one. I made sure that everybody has a calculator because there's part of it where you're going to need a calculator, all right? And it's not incredibly hard. This is not incredibly hard, but it's the one that involves technology with the calculator and some keys that people have never used before on the calculator. And so I'm just warning you up front, this is not a super easy day. Tomorrow will be easy. I'd like you to go to this purple page. And I'm going to pause for a minute while I make sure that everybody is on that page with me. We're all there. So now this one, to the 0 power. Do you guys know what anything to the 0 power is? Good. What's anything to the first power? Well, it's just itself. It's just a plus b. How about a plus b squared? Well, it does not mean a squared plus b squared. Headphone. Thank you. It means a squared, and it does end with b squared, but what's in the middle?
2ab.
2ab. And if you didn't memorize that, it's okay. It just meant a plus b times a plus b. 2 times. So this one, which nobody in here has probably memorized, is, well, it's got 4 blanks. Notice it's to the 3rd power, but it's got 4 blanks. Let's analyze that from before. This one here had a 2nd power, and notice there were 3 blanks. See how there's always one extra term compared to what power it is? Okay, so this is to the 3rd power, so there's 4 blanks. And I'm going to show you how to do what's called binomial expansion right here. So zoom in on this. And the first thing you got to do is say, I bet you some of you guys are going to know what's here. Somebody's just going to know the answer. A to the 3rd. That's all there is to it. Yes, this is a to the 3rd. I'm going to pick a smaller pen size here. Give me just a second. Tweak this down a notch. Okay, so a to the 3rd lives there. But I know we could probably jump around and know what the last term is, and it's just the ones in the middle that are hard. But here's what I think we should do. That's going to be a to the 2nd. This is going to be a to the 1st. And this is going to be a to the 0. And later, when you're good at this, you just won't write a to the 0 because what's that equal to? 1. See what happened there? Our a's went in descending order. A to the 3rd, a to the 2nd, a to the 1st, and then a to the 0. Makes sense so far? Okay. Now, b. I'm going to grab a red pen here for my b's, and I'm going to go b to the... somebody take a best guess here. B to the 0 is correct. Because you don't have the big number with the a to the 3rd, it's at the end. So this is b to the 1, this is b to the 2nd, and this is b to the 3rd. Does that make sense to you so far? Okay, well, there's only one more part that causes all the problems today, and that is there's a number in front of each of these, like a 1, 3, 3, and a 1, but don't write those down. There's a number like that in front of each of them. It's called the coefficient. All right, and here's how you get it. Put a parenthesis like this and put a 3 and a 0. Does anybody know what that means in math? 3 over 0 and a parenthesis like that. What?
Non-existent.
Nope, it's a good guess. I know you're thinking it's divided by 0. That's not a divide by 0. All right, see, that's why today is hard, and that's why we need the calculator to do this part, okay? But let's just follow it through. Would you agree if that's 3 over 0, I bet you can predict what's going to be here. 3 over 1, 3 over 2, and 3 over 3. Okay, so what the heck is that, Mr. Server? Because if you have that, that's it. You're done. That's all you have to do for binomial expansion. But what the heck is 3 over 0? So let's zoom in on that and figure out what is 3 over 0. That means 3 choose 0. And I think this is one of those things that may have gone the way of the dodo during the pandemic, because I've been getting a lot of blank stares from people about permutations and combinations, but I don't know. Does anybody remember doing permutations or combinations last year? You do remember. And I'm seeing some no's and some yeses. All right, so either way, I got to teach you because even if there's just 5 kids that don't know, I got to show you, right? So here's how you do 3, choose 0. I want you to understand it like with things. All right, so in the classroom right now, I'm showing them a Kleenex box, a name tag, and an orange. Would you agree that is 3 things? If I'm going to choose 0 of them, how many different ways can I do that? 1. So the answer to 3, choose 0 is 1. If I have 3 things and I'm not going to pick any, it's not complicated. There's just one way. You just don't pick any. All right. What if it was 3, choose 1? There are 3 things, Kleenex box, orange, and name tag. Hide this orange. Then, how many ways is there to pick one of the 3 things? Yeah, I could pick this, or I could pick this, or I could pick this. So there's 3. So the answer to that is 3. Now, it does get a lot harder when I do 3, choose 2. And that, again, would have looked like this, 3 over a 2, like that. This would have looked like 3 over a 1, and this would have looked like 3 over a 0. Okay, this 3, choose 2 is definitely harder, but it's still not impossible. I got these 3 things, the orange, the Kleenex box, and the name tag. Do you get, if I'm going to choose 2 of them, I could pick these 2, or I could pick these 2, or I could pick these 2. Do you agree that the answer is 3? Okay. Now, you can imagine, though, that if this was 7, choose 4, then it'd be way more complicated. You know what I mean? Like, it's going to get way worse. Because these I can just do, since there's only 3 of them, I can kind of do it in my head. So let's do it in our head, and we'll do it. We'll like show you how to do it when they're hard later. But this 3, choose 0, there's only one way to do that, so I'm putting a 1 right here. 3, choose 1, there was 3 ways. If you have 3 things and you choose 1 at a time, so that's a 1, that's a 3. 3, choose 2. When 2 things at a time come out, we had 3 ways. And last but not least is 3, choose 3. If I have 3 things and I'm going to pick them all, how many ways is there? 1. So that's a 1. Cool. Then we can get our final answer. I want to finish this one. Yes, question?
For like the stuff in the parentheses, how do you know like what goes in there? Because like for the first one, it's just like what's the...
Oh, why did we pick a 3? It was because this was a 3. You know, like it was 3, choose 0. We pick whatever the power is that you're putting your binomial to the power of, okay? That number goes there. And then you always just start with 0, and it's like all the other things. It just progressively moves. Okay, so 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3.
Just a coincidence that B was 0, and then B was 1, and 2, and then 3.
So this, we chose B to the 0 because that B was this part right here. And we're just going to do it alternating with the other one. The other one went descending. It started with a 3 and went 3, 2, 1, 0. The B's went up. They went B to the 0, B to the 1, B to the 2, B to the 3. Okay, so it was not like random. It was definitely chosen on purpose. And then those numbers in the front, it was 3, choose. I'm going to highlight them here. It was 3, choose 0. Blue's not a good choice. I'm going to go with red. 3, choose 0. 3, choose 1. 3, choose 2. 3, choose 3. It's very orderly, actually, if you think about it. It's just like a logical little progression. Now, I did warn you that if it was like 7, choose 4, that's not something you can do in your head. That's what you're going to need the calculator for, okay? But I just want to get the final answer for this. So here is my final answer. This right here, I'm going to make a thicker pen tip now. This right here all simplifies down and gives me my first term. So here's my first term. 3, choose 0. Already said that's 1. And then there's an A to the 3rd. And then there's B to the 0, which is also a 1. So the only thing that's actually left is just A to the 3rd. So my first term's A to the 3rd. This one, they were all positives because, you know, it's our first one, so we just did a plus. On this one, it was a 3 times an a squared times a b. Okay, so 3a squared b. 3a squared b. The third one was this 3, also a 3, ab squared, so plus 3ab squared. And last one is that's just a 1 times a 1 times a b to the third, so that's just b to the third. There's your first binomial expansion. So why is this in this unit? Well, in this unit, we got a whole bunch of sequences, like we go, 2, 4, 6, 8, and keep on going, right? Well, this has a whole bunch of terms, and they're all added together, which is kind of like a series. In the series, doesn't everything get added? Sequence is just a list of numbers. Series is where you add them together. So this is kind of like a series because these are all getting added. Sometimes there'll be negative numbers in here later when they're more complicated. All right. Okay, so on to this page. Why is this even here? Well, first of all, Pascal's triangle, this is Mr. Pascal. And he played around with and figured out this triangle, and it's pretty cool. Obviously, it has ones all around the outside. And if you look more at all the patterns in here, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 there. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 there. And to get from one row to the next, if you're like, so where are all of the numbers in the middle coming from? Like that 4 and that 6, because can anybody tell me where those are coming from? Like, let's pick one. This 3 right here. Where'd that 3 come from? Yeah, this one and this one. Where did this 4 here come from? The 3 and the 1. Make sense? It's just a fun little pattern. So why do you even bring it up, Mr. Server? Does anybody see the row that represents the coefficients that we just used? You see it there? Which one is it? 1, 3, 3, 1. Do you remember that? We had a 1 and a 3 and a 3 and a 1. Now, you might be like, well, that's a cool pattern. Will it work for all of our problems? Up until, do you get if I have 4 terms? These are the constants for the 4 terms. That's cool. But what if on the test, which we will, what if we give you one that's got like 16? This even 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You'd have to build this thing all the way out. And this has only got 11 coefficients. Do you get how it'd be such a pain in the butt to do it for if there was 16 terms? We're going to do one that big on your test. We're not going to make you do all the terms of it, but yeah, there's going to be a monster one. So bottom line, this is cool, and it would tell you when it's an easy problem what those coefficients are. But we need you to be next level on that, so I showed you how to do it with like 3, choose 2. All right, back to this. X plus y to the 5th. Let's just see how fast you can do this. How many blanks am I going to have? The most common answer that's wrong is 5. So what is it? 6. Everybody make 6 blanks. 6 blanks. Okay. And then we start with x to the 5th, and then we go down. X to the 4th, x to the 3rd, x to the 2nd, x to the 1st. And do I even have to write x to the 0? No, let's save time. X to the 0 just be 1. And then I do my y's. What do you think y is? Just don't say to the 5th, and then you'll be okay. So it goes the other way. Y to the 0, y to the 1, y to the 2, y to the 3rd, y to the 4th, and a y to the 5th. Okay. And then, okay, this is the pain in the butt part. You either have to write a gigantic triangle and make that Pascal's triangle, which I'm going to discourage because it can be done, but it's like, man, you got a ton of work just to make that triangle. And for the harder problems, you're going to have to know this way. This is 5, choose 0. This is 5, choose, what do you think? 1. And those we can do on our head. If I had 5 objects on my desk and I wanted to choose 0 of them, it would only be one way to do it. 5 choose 1, there'd be 5 ways to do it. But 5 choose 2 is starting to get difficult. And that's where I need to now teach you how to do 5 choose 2 and 5 choose 3 and 5 choose 4. 5 choose 5 is easy. If you have 5 things and you choose all 5 of them, how many ways is there? 1. And if you think about that triangle, you know how there was a 1 at the beginning and a 1 at the end? Always is. Okay. All right, so now let's teach you the last nasty thing, which is how the heck do you do 5 choose 2? All right, ready? Take notes on this. You don't have to write everything I said, but just write 5 choose 2 means 5 choose 2, which means I got to show you with factorials, which are those little exclamation marks, and I got to show you with the calculator. Why both ways? Why can't you just show us with the calculator? Because they can throw in a variable, and then the calculator won't work anymore. So granted, the calculator will work for most problems that you have on the test, and you're allowed a calculator on your next test. So this is my reminder. Those of you that don't have one with you, get one. I have had kids where they financially are not in a position to get a calculator. And if their parents contact me and explain that, I get you a calculator. I have bought kids their calculator and given it to them. So I will do that for you if you need that. I just don't want it to be a kid who's too lazy to ask mom and dad. So talk to mom and dad, have them send me an email saying, yes, we have that financial need. Then I'll get you a calculator, okay? So you'll have one for the rest of the year on me. You just have to have mom and dad contact me about that. So all I'm saying is bring your calculator or get one. Sometimes by now you've lost it or whatever. It's worth it. You will need it this year and next year and the year after that. It even usually works in college. Your first year of college, this calculator worked great. Okay, so back to 5 choose 2. That's 5 factorial over, try to learn it from what I'm doing here. You see where I got the 5 from? It's just the first number, okay? Then I wish it was just as simple as there's a 2 factorial on the bottom, but it's not quite that simple. There is a 5 minus 2 factorial, and then there's a 2 factorial. You could actually put the 2 factorial first if you wanted to. Wouldn't matter. Now let's make sure you know what that means. And some of you will choose to not even use the calculator because you can do it this way. And you might think, I'd much rather use the calculator. Well, it's kind of complicated to get to the right place to use the calculator. So you might like this better. 5 times 4 times 3 times 2 times 1. I wouldn't even write it all out once I was good at it. But I'm showing you because I'm trying to make sure you understand where I got it. Do you get the 5 minus the 2 as a 3 factorial? So that is 3 times 2 times 1. And 2 factorial is a 2 times 1. Now, a whole bunch of canceling can commence. Do you get that the 3, 2, 1 can cancel the 3, 2, 1? And I'm left with 5 times 4 is 20 divided by 2, which is 10. See how that really wasn't very hard math? Now, I want to also show you where that is on the calculator in a minute. I want to practice this one more time to make sure you get this. So that 5 choose 2 that we just did came from right here, and we got 10. So this is 10 for this part right here. All right, if you feel like you understand that, let's try to do 5 choose 3. This one right here. Go down. Do 5 choose 3 is really 5 choose 3. Why do you write it like that way? Because your calculator is going to write it like that. Equals 5 factorial over, somebody help me. 5 minus 3, which is 2 factorial. Oh, and then an extra 3 factorial. Now multiply it all out and see what that means. 5 times 4 times 3 times 2 times 1. Cancel a bunch of stuff. Now I'd like you to compare your final answer to the kid next to you. I'm going to pause for a second while we do that. A lot of people are saying it's 10. Let's just verify that. It's 5 times 4 times 3 times 2 times 1 over 2 times 1. And the 3 factorial is 3 times 2 times 1. And these are timesed. So cancel, cancel. Oh, 20 divided by 2 again. It's 10. Cool. Now, I do want to show you how to do 5 choose 3 in the calculator because there are a few kids that are going to get attached to the calculator to do this, which is fun. Okay, you ready? Everybody put in a 5 on your calculator. Now the complicated part is the choose thing, right? So but everybody get a 5 on the calculator first. Okay. Now, to get to the choose thing, I'm going to show you, and this is a little slower way to get there, but it's the most powerful button on the calculator. It's called the catalog button. Go above the 0 key. Do you see the word catalog? So hit second 0 and you'll be in the catalog. Now don't touch anything. Just look at the catalog. In the upper right hand corner, do you see a A? That stands for you are in alpha mode right now, which means the next key you press will take you to the right part of the alphabet. Now, the thing that you don't know, or you wouldn't know, and then why I think this kind of weird to find this thing, is your calculator calls this NCR. So you will find it under N. So everybody hit the green N. You know how the alpha keys are green? Hit the green N, and do you see NCR there? Then select it and hit enter. And your calculator now will say 5 NCR. But some of your calculators, this is that moment where I really hate TI right now because they came out with 2 different operating systems, so I got to explain it 2 different ways. Some people, your number will go right in the N spot. And other people, you're going to type 5 NCR 3 and you're going to hit enter. Other people, you're going to put it in here, 5, and then you're going to have a C, and then you're going to have a 3, and then you'll hit enter. Either way, it's 5, choose 3, hit enter, and what did you get? Raise your hand if you had 10. Okay, good. Now, there's usually a couple of kids who are like, I didn't follow that, I don't know what you're talking about. Okay, so we're going to flush that out right now and make sure, because I'm going to give you a tough one that only a calculator could do. And then you're going to work with the kid next to you, and if you're not getting how to do this, they can show you. Yes?
Wait, you have to go through the catalog?
No, there is another way, and I don't even want to address the other way. But why did I tell you about the catalog? Because it has every one of the functions on it. By teaching you that, I'm teaching you far more than just where that one function is. So if you want to go to the shortcut, there is a shortcut, but I'm not even telling you where it is, because it'll confuse people, and there'll be 2 different ways to find it. The catalog is cool, because if I actually later tell you to find the absolute value, it's like, where the heck is that? It's like, you'd be like looking for it forever, or just go right to it alphabetically. Okay? So that catalog is worth it, in my opinion. But you want to go shortcut? I don't care. As long as you can get them right, we're good. So would everybody please try 7, choose 5 on the calculator. And this is the part where when you compare with the kid next to you, if you're like, I don't get how to do it, then ask them to show you. Would you please hold your calculator out to compare side by side with the other kid? And if you need help, this is the part where you ask.
Is there?
If you really want to know the shortcut for this, it's under math. It's not super short, but the math key, and then you arrow over to probability, and then it's on the list there, okay? The reason I like showing you the other one, though, is because it works for anything you can think of. And it also gives you a list of things you didn't even know the calculator could do. If you're ever bored in a different class, pull out your calculator and scroll through. Like, look at all the things it can do. It's insane. Things you'd never find in 100 years unless you had that list. Okay, so 7, choose 5. What did you get, Cooper? Raise your hand if you had 21. Okay, good. So let's put it all together and see if you really got this. There are some questions like this on your homework. Where's the binomial, Mr. Server? Well, we're just making sure you get what these mean. Do you remember what I said? Maybe I never said it in your hour, but do you know what 0 factorial has to be? Otherwise, there would be no answer for this.
1.
It has to be 1. Very good. 0 factorial is defined as 1. So this is really 3 times 2 times 1 times 2 times 1 over 1. And you should be able to do that in your head. Did you get 12? Then you're getting how to do those. Okay, good. Let's move on to the next page. What is that? Well, That is the definition that I showed you a second ago. You take the top one and put it on top as a factorial. Then you take the top minus the bottom, and that's a factorial. And you have an extra one of those on the bottom. Okay. What are these good for again? In a really short one, it's only got like 4 terms. You could just memorize that it's 1, 3, 3, 1. I wouldn't. I don't think it's worth your time. I personally just learned how to do it the hard way. It's kind of like the quadratic formula. The quadratic formula works no matter whether the thing's got irrational answers, whether it's got perfect, nice, clean numbers, and the quadratic formula also works for imaginary numbers. So it's just like works for everything. So the way I just showed you works even when there's 17 terms. This can't. Okay, and here's the part where I show you which ones I would do. If you're new to my class, I don't just assign all of them because I think that's not realistic. You're probably not going to do all of them. So I try to give you a subset. I would do those two. I would do these two. Got those circled? Okay. I think this is honestly too easy, but maybe some of you need easy mode. I'd do that one because that's more like what we would test you on. It's got a negative in it. It's got a 2x. We should talk about that, though, for just a second. Let's even start this homework problem together. How many lines is it going to have? 5. And as I go across, I'm going to do 2x to the 4th, and I'm going to do it wrong on purpose. What did I just do wrong already? Yeah, 2x parentheses to the 4th, because otherwise only the only the x would be putting to the 4th. We want both to the 4th. So it'd be 2x to the 3rd, 2x to the 2nd. I think you're getting the idea. And that negative goes on the 1. So when you do the negative 1, you're going to do negative 1 to the 0, which is 1. Negative 1 to the 1, which is negative 1. Negative 1 to the 2nd, and it slowly rises. Where the other one slowly descends, this one slowly ascends. And then how do you get the constant? Not the constant, sorry, the coefficients. 4 choose 0. This one here would have a 4 choose 1. I can do that in my head. 4 objects, pick them out one at a time. The answer is 4. But if you need to, you can either do 4 factorial over 4 minus 1 is 3 factorial with an extra one of these. You can do it that way, or you can use a calculator for NCR 1. There's a review of everything that I've taught you. And this page, said skip that one and I do the last one. And that's it. I think if you did those, you'd be in really good shape, understanding it well. Test is coming on Tuesday of next week. And what we just covered today, that's like some of the hardest problems. And it's at least 2 or 3 of the questions on your test are what I just taught you today. So well worth your time to practice it tonight. All right. That's all I got for you for the video for today.